Hello, my fellow YouTubers. This is Roy again. There's the moon. Half a moon. And there's a star. That is. Right there. That's crazy. Look how bright that star is. Well, let's go and do another experiment. So tonight we're going to do some RF experiments, and I have the oscillator here, and basically what we got here is 24 volts going into this DC motor controller so I can control the voltage. The two batteries go into the DC controller. Coming out of the DC controller goes into the bifilar. The bifilar has an iron core, a laminate core. When the coil is connected in a closed loop circuit to where there's the positive negative going each end of the wire, creates a magnetic field. The core becomes magnetic. It pulls this back and it breaks contact. When it breaks contact, the magnetic field reduces, the electric goes back out the coil, and when it does that, then it makes its connection and it does the process again to pull it back. That's how this thing works. It's an oscillator. Now, the reason it's a bifilar has nothing to do with this experiment. Well, if you notice, I got two loose wires, and that's the second wire. Now there's a 26 gauge wire that we're connected to, and then there's like a 22 gauge wire or 20 gauge wire that we're not using right now. So basically you can use a single wire, and this is a make or break contact, like a points set up from the old Model T Ford. You can buy brand new, even though this is from a 1912, 1914 Model T Ford, you can still use these points. And they're dirt cheap. They're like $7. You can buy them online. So I'm coming out of the two contacts because one side here is positive, one side here is negative. Okay? And the way we got this going is I'm hooking up the frequency counter to one side of the positive and then one side of the negative. So every time it makes a contact, the frequency counter will count. It's in 0 in hertz right now. And it goes to show that the voltage controls the speed. But what happens here is when you go up in volts, the magnetic field gets stronger in the coil. So it wants to keep this metal piece back further. It pulls it back further, which slows down the frequency. So you can see when I start off, it goes from 0 up to about 300 kilohertz. And as I go up in voltage, which the voltage will show up here, it will go down in frequency. Now we're going to check RF. Now, as well as coming off to the frequency counter, I'm also coming off with just two wires, and here's the negative up top, and the positive is down bottom. Let's verify this. Yep, this side is the positive, and that side's the negative. So if you think about this, I'm coming into the coil right here from the positive side. That runs through this whole windings, comes out the back end, and then runs right to the one side of the polarity poles here. Then the other side is connected directly to ground. So when ground and positive make a contact here, it is putting a double helix field going through the wire, which makes the magnetic field, because you can't just have positive running through the wire and nothing's going to happen. But the magic which is beautiful magic, happens. The second this makes contact, this whole apparatus has a two-way highway going. So you got energy running one way in a corkscrew manner, and energy running another way in a corkscrew manner, and the winding dictates which side has what pole. And I also have two little magnets sitting right there, neodymiums. So the magnetic field is, I believe, opposing the field of the magnetic field of the core is opposing the magnetic field of, no, actually it's contracting. So the contraction part is that this is probably a opposite pole of the field of the coil, so it pulls it back. And then when this contact no longer has the magnetic field, there's a withdrawal in the energy through the coil, and then it collapses the field, and the field goes and releases itself like a spring. It's pretty cool stuff. This is the best experiment I ever done in my life. I got to give kudos out to everybody who's been working with electromagnetic field, but I obviously have to give big kudos out to Jacob Lewinsky. I mean, he just sent me in the right direction. You send me in the right direction, I'm your hound dog. I love this stuff. I should rename my channel The Experimenter, because I'd love to experiment. So in regards to here, we're also coming out to where you have here a dipole. This is what RF is. It's a dipole. And it's, what's happening is you have a positive and a negative. Let me verify this. So the positive side of this coil is going to ground. And it doesn't work too good the other way. If you send ground to ground, it doesn't really work. So you gotta send the positive to the ground. If the ground is normally normal, it's attracting this energy. The negative is up in the air. And I'm going to use here a LED light. And the key with LED light is, if you want to go into RF, that is a Germanium diode right there. And I got a pack of these Germanium diodes. I keep a lot of them. There's different sizes, but these Germanium diodes are awesome because you can see there's a band on the top. It's darker. And for the one experiment, we're going to check the RF here. I also have the bottom going to ground. So with that ground, if it's not connected to ground, it still works. But it doesn't work in other ways, meaning like we're going to walk out of this room and we're going to go touch my house and other parts and metal parts, bringing in a magnet. Like over here, I have a neodymium magnet just sitting here. And I also have a full wave bridge rectifier that I made out of germaniums. So not only are we going to light up LED wirelessly, we're also going to be able to pull electric from that. And what the germanium diodes, if you guys don't know about them, they're very different. They're responsive to electrostatics. If electrostatics have any displacement in the electrostatic, it'll show up into the germanium. And NASA knew about it back in the 70s, and they used germanium. And let me see, let's go over here, look on the periodic table, and germanium diodes should be somewhere over here. Number 32 is germanium. And NASA, back in the 70s, when they did their wireless test, they used number 31, gallium. Gallium and germanium. And interesting thing about these two on the atomic chart is that they're crystal lattice. Very important. And here's the rock that I found that was in my ground. And here's a rock that was from Coral Castle. Now, according to Dr. Kowsky, he's saying that the lattice makeup in crystals, some are in the same lattice setup. And if they're in the same lattice setup, which these would be, they all have crystals growing out of them. I don't have one of Ed's rocks here. This is from Coral Castle area. And this here is from my area, which is North Florida, South Florida. And obviously crystals grow. And what we're going to do in this test, the first thing, is we're going to see if we can take a crystal. Now this crystal here, let me get a piece of white paper. That crystal there is a quartz. And see how it's kind of clear? Okay. Now I exposed it to a combination at a certain frequency between the two of electrostatics and RF, and this happened to one of them. And I want you to notice the difference is that look how milky that is. And it wasn't milky when I started, it was clear like that. And that's like one day of messing around. There's still some clearness here. So the doctor Kowsky, he talks about this. And what happens is once it becomes opaque and you turned it all milky, it starts to grow. It starts to expand. And in the crystal lattice of the crystal itself starts to take the molecules, expands in the electrons. And that's where this would grow bigger. And this is where that electrons would be able to levitate. And here's where the rocks come into play. Because the rocks already have a built-in memory of the crystal that's in the rock. So I believe Edley Scallon, through sound, which sound instruments are made of piezo crystal, such as speakers, loudspeakers, and microphones. And these things are important. We don't talk about it's in front of our face, I believe. So the exciting part of this, we'll use the full wave bridge rectifier over there. And I'm not going to hook up a voltmeter to it. Well, I guess I could. Voltmeter's right here. Oh, why do we have to be so good? So let's go ahead and turn that sucker on. And we are going to put it on 20 volts. And I'm going to have one hand, so we are going to take some of these wires so it could do the work. And we're going to start it off running off the DC side. So on the full wave bridge rectifier, who here knows how to make a full wave bridge rectifier? I'm looking at this, and you know what? Yep. So the LED runs vertical here, and that's the DC side. The positive of the DC is where the 2 points come together, and we're going to connect on the positive side. We'll connect the negative to the negative side here, and then we'll get one more wire, and we'll connect the positive side of the voltmeter, and we'll connect it to here, and we'll see if anything shows up. I really like for this to be vertical so we can see it, so hopefully it don't fall. And just right now, it's just sitting there. You can see it's got something showing up. And you know what? I'm going to predict that is just natural medium noise, we'll call it. So let's go ahead and add some volts. And remember, the volts are going to show up here, but it won't show up until it gets about 12. There you go. So we're going to get to, there you go, 11.1. Let's go over here, and you got the light is on already. And you can see volts is showing up here. So this is 0.22 of a volt. So voltage is showing up over here. You can see the LED is on and nice and bright. Over here we have our oscillator oscillating. And over here you can see our frequency meter. Let's put the light back on. All right, so we are sitting at a frequency of 100 and see, that's one thing about, this is why they were working with crystals. The reason back in 1919, 1900, 1880s, when they were messing with RF signals, they couldn't keep the frequency the same. And you can see how it bounces around. Okay? And we're at a lot of kilohertz, 100 and some thousand. And we could take this one LED that I have set up to the germanium. Now, if I touch this side, you can see the light lighting up. Look at that. There's RF right there. Lights lit up. So if I follow the ground wire down, you can see the light really don't, right there it lights up. Now it's real bright. Here's your RF. Now if I take the full wave bridge rectifier, which you can see the voltage over there, if I take it, let's say I walk off with it, the voltage is going up. Look at the voltage. So I'm raising this up in the air. And we're getting more power coming out. But let's disconnect the meter from it. Because what I'd like to do is show you guys, you can walk with this. All right, so look how much more powerful it is. I'm out here. Let's turn the light off. Oh, well, anyway, to the kilohertz. We're at 11 volts. Let's go ahead and we're going to go up in volts, which is making a stronger magnetic field here. And what you're going to see is that the frequency went down to 70s and 80s, and the LED is barely lit. It's lit, but barely lit. Now, as I change the voltage down, the frequency goes up and the LED lights up from far away. So you can see going up in frequency by adding, but decreasing the voltage is critical here. Now you can see another thing is, let me disconnect the light, and you can see I'm not even touching it now. I'm just in the air. So here's your RF. Voltage not even showing up. This thing is humming at. We're going to change that frequency to better. Let's get better. Ooh, hear that sounds? A higher pitch. Oh yeah, look at that, 280,000. I'm adjusting it right now to get it up. I want it over to the 2s. Turn it off. Turn it on. Alright, we're up in the 2s. Alright, that's a lot. Look, I'm out here. Here's your RF. So we're sending out, what's happening with the RF is that it's building and collapse in the field, and this one end of the positive and one end of the negative, which is up in the air vertically, and the positive is heading down, connected to ground. It's making the ground to be a pole and the air to be another pole. So you can see there's your RF, and it's picking up in the germanium, and not only is it making electric to light up the light, it's also producing electric to be able to recapture. Let's go outside here. Back to that beautiful star, beautiful moon. They were lined up last night pretty good. And we're gonna go outside here. This is crazy. So let's connect one of the wires to the, oh no, you know what we'll do? I got a better idea. Gonna make this loop again. And what we're going to do is use that magnet, because I'm gonna go to the drip edge of the building, okay? This is the drip edge to the building. I'm gonna connect the magnet. And right now I got the LED connected to the magnet off the drip edge. Look how bright that is. So the drip edge to the building, the drip edge. Now we're going to go over to my train. I know you guys hear it. I don't know if we can get this off my building here, my window. You're not going to see that. I can't do that in the dark. One hand. But you get the gist. So, like over here, this is that's the tracking for the garage door. And watch this. We're just going to let the one end. Look at that. That's just RF right there, coming off of here. So let's do this. I want to show you something pretty cool. So I can control this light by that gauge. Look at that. I'm very important to this equation here. Something wrong. Anyway, you guys got the gist. Great experiment. RF. You guys, leave your comments. Peace out.